Welcome to EPG Pathshala, a series of lectures on computer science, and we are looking at computer networks. In today's module, we will be looking at IP options and ICMP. So, learning objectives for today's module are the following. So, we will look at the different options that are there in IP, and we will look at the error reporting protocol, the ICMP protocol, or the Internet Control Message Protocol, which is the companion protocol for the IP protocol. So, we will look at different types of ICMP messages that are there and the different uses of these ICMP messages. So, let us start with the IP options. Now, if you look at the IP datagram format, which we have been looking at for quite a few modules so far. So, we have covered most of the all the header fields which are there in the header in the standard header. We have looked at header length, type of service, length, identifier, flags, fragment offset, time to live, and then the upper layer identifier, header checksum, source IP address and destination IP address. So, the one field that we have not looked at so far is the options field, which is what we will take a look at now. So, if you look at this options field, there are various types of information that can be gathered or specified in this options field. So, you could have something like timestamp information that can be recorded, you can record the route taken, you can specify some source routing options that are available. Okay, these are various things that we will be able to do. So, these are options that are provided in IP, and how these are used are of course up to the user or the network administrator or a network designer and so on. Okay. So, if you look at this options field, okay, the options field basically consists of all this information. There is a code which specifies what type of option is being given here, right. So, you have a code field and then you have a length, a pointer and some variable data. So, if you look at this code field in turn it has the following subfields. It has one bit called the copy bit, and there is an option class and an option number. So, the option class and number together identify the type of option, and this copy bit, it is a very special bit which basically says what we should do with this options field when this particular IP packet is fragmented. That is, if and when this IP packet is fragmented, should this options field also be copied into all the fragments, or can we leave out this options field? So, that information is specified by this copy bit. So, if the copy bit is set to 1, it indicates that you have to copy it into all the fragments, otherwise it could be left as such. Okay, so, that is the purpose of this copy bit that we have here. Okay, so, let us look at the different types of options that are available. The ones that we will be focusing on are these 4 different options. Okay. So, we look at the source routing option. In source route, the meaning of source route is that the source specifies the complete route that is to be taken to the destination. So, you are not depending on a routing protocol, but you are depending on the source to specify the list of IP addresses of the intermediate routers that the packet should go through before it reaches the destination. So, you have the complete route specified in the packet itself. So, we have an option to specify this route. So, there are 2 different types of source routing that are supported. One is called strict source routing and the other is called loose source routing. So, in strict source routing, you will have a complete list that is specified, right. So, that is every single intermediate router that the packet has to go through is specified as a strict list of nodes or addresses that have to be gone through. Now, in loose source routing, it does specify a set of nodes, but to go from one node to another, you could also go through some other nodes which are not specified in this list. So, it is a kind of loose specification, here it is a strict specification. So, this is what is done with source routing. Another option that we have is record route. Now, in record route, you are this can be used for any packet where you want to record the route that is taken by this packet. That is, you want to record the addresses of the intermediate routers as the packet visits before it reaches the destination. So, timestamp again is similar to record route in the sense that some information is recorded as the packet goes along, and here what we are interested in is in the timestamp. That is the timestamp at which the time at which it visits each and every one of those routers. That information is recorded here in the timestamp when the timestamp option is used. And of course, so we have different option numbers that are used to specify this, and the length of each of these things is variable because the amount of information that is to be specified is variable. So, we will take a look at the format of each of these now. Okay. So, in strict source routing, as we said, it will specify the complete route list for a packet to take on its journey from the source to the destination. So, the packet format, the options field format will look like this. You have the code length and pointer, right. So, this pointer basically points to the particular address that we need to be currently looking at. Okay. So, you have various IP addresses specified here. You have the IP address of the first router in the path, second router in the path, and so on up to nth router in the path. So, this basically says that you need to be looking at these rows. So, initially the pointer will be pointing to the first router. So, when this packet is received, all that the router has to do is look at this router address, okay, and point to, look at the next router address it has to go to and update the pointer appropriately. So, get this address from the information specified here and forward it to that particular address. Okay. So, the last address in the list will replace the address in the destination field. So, that is to indicate that it is finally reaching the destination. So, you will have a complete list here of all the routers that it has to visit before it reaches the destination. Okay. The complete path is specified. So, next is loose source routing. So, loose source routing you can say is a partial route list. It is not a full complete route list, but it is a partial route list for the packet to take on its journey from the source to the destination. So, here again the only where it becomes a loose source routing is that the packet definitely has to visit the different routers that are specified here, but it is allowed to visit other devices or other routers also when going from one router to another. So, to go from router to 1 to router 2, if it were to visit some other router 10, okay, that is allowed. Okay, you can allow it to go from router 1 to router 10 and then to router 2, but it definitely will visit router 2. In strict source routing, you will not be allowed to go to router 2, 10, you will have to go from router 1 to router 2 directly. Okay, so that is the idea that is used here. The fields are pretty much the same as what is specified for strict source routing. So, the next option that we have is the record route option. So, in record route, you instead of specifying the routes as we did in the case of source routing, here when the node visits a particular router, its IP address is recorded in the options field. So, if you see the kind of fields that we have are very similar. Only thing is all these fields will be empty when you start with. So, when the packet first leaves the source, all these fields will be empty, and as it visits the different routers, the router information, the address of that router information will be filled in over here. So, when it visits the first router, the information is filled here and the pointer will be pointing to the next router. So, when it goes to the second router, it looks at the pointer, it finds that there is an empty field there, right. So, it will fill its address and increment the pointer, so it points to the next address. So, in this way, the each router will fill in its address as the packet goes through that particular router. This is what is done in this record route option. Now, what is the purpose of this? Basically is to find out what is the route that your packet is taking, and the destination machine can extract this complete route information and it can process that route information and take whatever decisions that are required. It may be for debugging purposes, or it may be just for measurement purposes, it may be for whatever network management purposes. Okay. The only limitation that we have here is on the size limitation, which is that you have a limitation of 40 bytes for both the option and the storage space. So, this can normally record only up to 9 IP addresses. So, if you visit more than 9 IP addresses, obviously you will lose that information. So, that is one of the limitations that we have with the record route option. The last option that we will look at is the timestamp option. So, in the timestamp option, what we have here is that the time at which each network device, that is each router receives a packet, right, that is recorded. So, you can see what we have over here. So, you will have just as we saw in the case of the record route option, you have the IP address of the router, and along with that you also have the timestamp information. So, actually there are this timestamp field actually has two different fields that need to be filled in. One is the IP address of the first router, of the router in the path, and this timestamp of the first router. Similarly, for every router that it visits, the IP address of that router and the timestamp of that router will be specified. Okay. So, you also have an option of specifying the IP address and saying that only those timestamps have to be filled. So, these are kind of variations that you have, but you can say that this timestamp option is kind of a superset of the record route option, because in record route only the routes are recorded. Here we see that not only the route, the address, but also the timestamp information is recorded. So, with this timestamp information you get a very clear idea, the destination can get a very clear idea of the time taken by this packet as it comes from the source to the destination, and the time that it spends at each of the routers. So, if a particular router is congested, for instance, it would know, because it would find that it spends quite a lot of time at a particular router. Okay, so that kind of information can be gathered from the timestamp field. Okay, so these are the various options that are available for us. Okay, so the next thing we will be looking at is the error control mechanism that is specified along with IP. In fact, it is not an error control mechanism, it is actually, I would say it's an error reporting mechanism. That is to say that we have a protocol called the ICMP protocol that is specified or that is used along with the IP protocol, which is used to report errors if and when they occur in the network. Okay, as the packets go through the network, if there are any errors that occur, so those can be recorded, they can be reported. Another reason why we can call this maybe as where we could call this as an error control protocol is that you can get some status information. So ahead of time you could get some status information, and based on that anticipate errors and try to control errors. So in that sense ICMP can be considered as an error control protocol as well, but normally we refer to ICMP as an error reporting protocol. Okay. The reason why we need such error control protocols is obvious, because we definitely know that something is likely to go wrong, right, at the routers or at the end host or somewhere. So in case something goes wrong, and we know that IP is the best effort protocol, so we definitely want to know if and when something has gone wrong, what it is that has gone wrong. So there are some status messages and some control messages that are given as part of this ICMP protocol. Okay. So this ICMP protocol itself, okay, the ICMP message that we have is carried as part of a IP packet, which means you have the ICMP data, there will also be an ICMP header, right. So this ICMP data plus header becomes part of an IP packet. So this becomes the IP data, and it will be encapsulated in an IP datagram. So an IP header will be added to it and it will be sent. So this ICMP message, which consists of all the information that we want to specify about some error or some status, that will be passed on using an IP packet to whichever destination we want. Okay, so that's the idea of this ICMP protocol. Okay, so we say ICMP runs over IP, though we look at ICMP as a layer 3 protocol. It's interesting to note that it actually runs over IP. It's carried in IP packets. Okay. So if you look at the packet format, okay, in fact now we have ICMPv4. There are two versions, v4 and v6. v4 is used with the IPv4 and v6 is used with the IPv6 version. So if you look at the v4 packet format, okay, you will find that typically this is the information that you will have. You will have a type field, you will have a code field, you have a checksum field, and you have a data field. So the type field and the code field, the type and code together specify what is this type of message that is being carried, right? And there are some subdivisions which in that they are specified by these two fields. Checksum is a normal checksum that we have, the same checksum that is used in IPv4 for instance. That is the ones complement checksum of addition of all the fields that are there, right. So that's the checksum, and then you have some data. So the type and code, as I said, they used to identify the error event, okay, and the data field contains the IP header plus the first 64 bits of the packet that elicited the ICMP message. That is, if a packet is in error and an ICMP packet is being sent for that purpose, then this data field will contain some information about that packet. So what is the information about that packet that we would like to send? We would definitely need to know what that IP header actually contains. So that IP header is sent as such, plus the first 64 bits of that packet. Okay, this is what is extracted and sent as part of the ICMP message. Okay. Another reason, of course, these are things that you can see have developed through various RFCs, and the standards have kind of evolved to provide more and more information. Okay. So if you see RFC 1122 for instance specifies that the IP header and at least the first 8 data octets of the datagram that triggered the error, right, could be sent. Of course, more than 8 octets may be sent, but it specifically says that 8 data octets should be sent. Okay. And again, in RFC 1812, there is a requirement which says that the information should contain as much of the original datagram as possible without the length of the ICMP datagram exceeding 576 bytes. So as you can see, starting off from 64 bits, which is about 8 bytes, we say more than 8 bytes, and we say up to 576 bytes of information can be sent as part of this data field. Okay. So this is, so and the data field normally is taken from the IP packet which is causing the error. Okay. So now let's look at the various ICMP types that we have. So if you look at the ICMP types, we have something called an echo request and an echo reply field. Okay, so this is one. Then there are a number of fields which talk about destination unreachable. Okay, so you will see that the type here, okay, indicates 3, type 3, and you have different codes there. So this type 3 indicates that some destination is unreachable, and the code here specifies why the destination is unreachable. The destination could be unreachable because the network itself is unreachable, or it may be the destination host that is unreachable, which means you can reach the network but you are unable to reach the host. The third one is your destination host is reachable but the protocol is unreachable. So which means you are not able to reach UDP or TCP, whichever protocol this packet belongs to. The next option we have is the destination protocol is reachable but the destination port is unreachable. So that is the UDP or TCP port which is specified, that is unreachable. Okay, so these are different destination unreachable options. Plus, you may also have a situation where the destination network is unknown or the destination host itself may be unknown. Okay, so these are again other destination unreachable options. In addition to that, if source routing was specified, it is possible that the source routing failed because for some reason you are not able to follow the path that has been specified as part of the source routing option. So that also will lead to an ICMP error saying that the destination is not reachable. Another option that is possible is that now as the packet goes along the path, somewhere at some link fragmentation may be needed, but it is possible that the don't fragment flag, the DF flag which is there in the IP field could have been set. Now when a DF flag is set, it means that this packet is not to be fragmented. But if fragmentation is required and the DF flag is set, obviously you will not be able to send this packet along to its destination, in which case you will not be able to reach the destination. So that also becomes a destination unreachable case. Only thing is, the reason is that fragmentation is needed and the DF flag is set. Okay, so these are different ICMP types that are possible under these two categories. There are further more categories. Okay, so we have something called ICMP source quench. Okay, now this particular message is basically used for congestion control purposes. That is, if a router is congested, it could send a source quench message. Basically, all this tells is, it tells the source that look, I am getting congested, so you please reduce the amount of data that you are sending. So this is actually information to send to the to layer 3. Unfortunately, IP does not directly do any congestion control, but this option is provided by ICMP, so that it could be used if necessary by higher layer protocols or when the protocols evolve. Okay. In addition to that, we also have some redirect messages, which means that you are specifying a redirection, asking it to take a different path to reach either a destination host or a network or a destination host. Okay. So then we also saw something called echo reply. So there is also an echo request. So this echo request and reply are very, very important fields, types of messages, because they are basically what are normally used in the for the ping command. Now all of you I am sure would have used a ping command whenever you want to check out if a particular node is working in the network and so on, right? Especially in the lab or even when you are just trying out to connect to some particular remote host. So you just do a ping and specify the IP address. So what happens in that case is that actually an ICMP message is sent. That is, we send an echo request message. An echo request message basically says that send this message to the destination and you are telling the destination to send an echo back. Now you remember what an echo is, right? So whatever you send comes back to you. So it will send an echo reply, right? So this is the first message that we saw. It will send an echo reply message. So you can see that this echo request and reply, this combination together, right, was used to check whether the path is correct, whether the destination is up and active, whether it's able to send back a reply. All these things can be checked with this. So which is what the ping protocol basically does. So if you see, when you use the ping protocol, you will see that number of times this echo request will be sent and replies will be got, and the timestamp at which the request was sent and the reply was received will be recorded and will be shown to us. Okay, so this is what we is the importance of this particular message, echo request and reply. It is used in ping. Okay. In addition to this, we also have route advertisement messages, router discovery messages. Okay, and this is another very important message is the TTL expired message. Whereas we know that time to live is something which is specified in order to make sure that an IP packet does not live forever in the network. That is, normally the way it is implemented is that at every hop the TTL field is decremented by 1, and when the TTL field goes to 0, we drop the packet. So if the TTL field goes to 0 and we drop the packet, that information has to be specified back to the source, and that is specified by means of an ICMP TTL expired message. So when a TTL expired message is sent back to the source, it knows that the path, either the destination is much longer than the TTL value that was specified, or something has gone wrong. Okay, so these are the various things that we have. Of course, the last one, of course, that we have is a bad IP header, which means it's some parameter has gone wrong, right? The IP header is something wrong with the IP header, so then a bad IP header is sent. Okay. So we'll just take the details of some of these messages that we have. So we talked about the echo request reply, right? So if you look at the echo request reply message, it has the type field, the code field. We've already seen what these fields are, checksum, okay? And then it has an identifier, sequence number and some data. Now this identifier and sequence number together, okay, are used to match the request with the reply. So whatever information sent in the identifier and sequence number in the echo request message has to be sent back in the reply message, right? So same information has to be copied back, so that the source which sent the echo request, when it gets back the reply, will be able to match the reply with the request and identify that the path is correct. Data that is specified here is any data could be specified, and this data also will be replied back, will be echoed back. Okay. So this again is basically to check that the end machine is able to extract this information, process it and send it back. Okay. So this is the how echo request and reply messages are specified. Okay. Then we looked at the destination unreachable messages, right. So in the destination unreachable messages, it could, as we saw, that it could be network unreachable or host unreachable or port unreachable and so on, isn't it? Okay. So in that case, okay, if a particular packet is not able to reach the destination, so what's the information that needs to be specified here? This is what is specified. You have the type and code fields, checksum, okay. This field is empty. You have the next hop MTU. Now the next hop MTU normally is specified when if it is because of a fragmentation related option, okay. Otherwise, okay, all these destination unreachable messages, the type 3 messages, will have the IP header plus the first 8 bytes of the original packet's data. Okay. So the packet which was not able to reach the destination, information about that packet is specified over here. Okay, you can see that this information is copied over here. Now this next hop MTU, why is this specified in case of fragmentation needed? Because we need to know what is the size of that maximum transmission unit there, of the link layer there, so that we will know why this fragmentation was required. Okay, you get to know about the size. Some information about why fragmentation required is specified over here. Okay, the source quench message, if you look at, okay, this is another the third type of message that we have. So you have a type, code and checksum, okay, and there is just some data which is specified. The data field could also be empty. Okay, so this basically is just the type and the code give us sufficient information about the source of, about what this message actually is trying to convey to us. Okay. So next is the routing redirect message. So when you want a routing redirect message, basically you need to specify the address to which you want to do a redirection. So that you will see that the gateway router IP address is specified here. Okay, you have type, code and checksum which are the same, plus you have the gateway router or the IP address specified. Okay. And we said that if there is a header error, a wrong header, okay, so then the code field, if it is 0, it indicates that the IP header is invalid, and a code value of 1 indicates that some required field is missing, okay, a required option is missing. So in which case again you will find that you will just send back the IP header plus this, plus the first 64 bits of that particular packet. Okay. Another option that we have is a timestamp request and reply. Just as we had echo request and reply, there also is a timestamp request and reply option. So in the timestamp request and reply option, which is very similar to echo request and reply, you send a request and you expect a reply back. In the timestamp request, what is also sent is you send the timestamp information. That is the time at which the packet is sent from here and the time at which it reaches over there. And when a reply message comes back, it will come back with not only the information that was sent from here in the request message, plus additional information which tells us about when this packet reached the destination on their side and when the reply was sent back. Okay, so all this information will be there. So information request reply, address mask request reply, these are certain other similar messages that are specified for us. Okay. One of the very important messages that is used, that is very commonly used, among these different ICMP messages, the time exceeded message. Now we saw that whenever the TTL becomes equal to 0, you drop the packet, then you will send this a TTL time exceeded message. Okay. Now this time exceeded message has a very interesting use. Okay, it can be used to implement a traceroute implementation, implement a traceroute option. Now remember what a traceroute command is. A traceroute command basically is something which will allow us to trace the route that is taken to go from a source to a destination. Okay, so how can I implement a traceroute command using this this kind of a time exceeder or an ICMP kind of message? Okay, so let's look at that. So what we do here is, when you send out an ICMP, you send an ICMP echo request message with the TTL value equal to 1. So what will happen in that case? At the very first router, when it receives the message, right, TTL will be decremental, go to 0. So immediately it will respond with a time exceeded message. And when this time exceeded message is sent, I know from which router it has come. So I have got the address of that router. So I know the address of the first router. Next you send another message, same echo message, but with the TTL value set to 2. So when the TTL value is set to 2, now what happens? It will pass the first router, but it will be discarded the second router, and the second router will now send a time exceeded message. The second router now will have, now I have got the address of the second router as well. Now you keep doing this, right? Keep incrementing the TTL value and keep sending the packets. You will find that you start getting TTL exceeded messages from the first router, second router, third router, and so on. Okay, until TTL exceeded messages, but you get back an echo reply message. So by doing this, you would have got the complete path, right? All the IP addresses of all the routers which are in between. So this is a very interesting use of this time exceeded ICMP message. Okay, okay. So you can just see what is happening here. So for instance, in this example, I am sending out first one message, right, with the TTL equal to 1, that came back. Now TTL is equal to 2, so now this will send back a reply. TTL equal to 3, this sends back an ICMP message, okay, and so on. So until of course I reach the final destination, you will find that I can get back all this information. Okay, so this is what is normally done. You could either send an echo request reply, or you could just send an UDP segment. So that also is normally used, right, in order to find out whether find out the complete path that you have to get. Okay, so that's a very interesting use of this particular ICMP message. ICMPv6, as we will see, it has many more message types than the ICMPv4 messages. So you will understand this ICMPv6 message better if we take a look at the IPv6 protocol. But right now, this information here is basically to tell you that there is a lot more information that can be specified as part of the ICMP messages. So we have many more control messages, we have many more error reporting messages that are supported in ICMPv6. So to summarize, what we have looked at in this module are two things. One is the IP options, where we looked at the different options: source routing option, record route option, and the timestamp option. And then we looked at ICMP, we looked at the different message types that are there, and two important usages of ICMP messages, which are ping and traceroute. Ping implemented using echo request and reply, traceroute implemented using the time exceeded kind of a message. Okay. So, so with these messages, there are a lot of interesting things that can be done. So, which is what we have tried to provide an overview of. Thank you.